So we've looked at the history and who came up with some of these ideas. We know that these ideas are not particularly right, such as the sun does not move around the earth, the stars do not move around the earth, and so forth. But those ideas are still very useful. And we can picture this, at least in the ancient Greek view, as the earth at the center of a great sphere or circle of stars, a three-dimensional circle of stars all around us. So this becomes known as the celestial sphere. Celestial means of the stars. Stars out there in the outermost sphere, the planets move around inside. They don't show up in this picture, but you can kind of imagine the planets, the sun, and the moon also being in here. There are a few locations on the sphere we need to look at. First of all is the celestial equator. Earth's equator divides the Earth in half from the northern hemisphere and the southern hemisphere. The celestial equator divides the sky in half, and it is directly above the Earth's equator. It is shaded sort of bluish green in this picture. It is tilted a little bit, as we will see why when we get a little bit closer to some of these things that we're going to talk about. So it's directly above the Earth's equator. You also see the North Celestial Pole and the South Celestial Pole. Those are directly above the poles on the Earth. So if you go to the South Pole and look up, you will be looking at the South Celestial Pole. If you were to walk outside, day or night, point straight up into the air, you will be pointing at the zenith. So the zenith is directly overhead, straight up. If you were still outside and the Earth were clear and you pointed downwards all the way through the Earth to the celestial sphere on the other side, you would reach the nadir. Nadir is the low point, so it is the point directly below. Then there's the horizon. The horizon would be where the sky appears to meet the land or sea. So if you see the zenith straight up, your horizon's on either side, or any which way you look around, where the sky appears to meet the land or the ocean or the water, whatever you're around. There's one more point on this that we need to look at here, and we're going to look at into a great more detail, is called the ecliptic. Ecliptic, ecliptic. The ecliptic is where you find the apparent path of the sun, the moon, all the planets. And we can throw in all the asteroids, most of the comets, not all of them, but all of those things that we tend to associate with the solar system, they move, if not directly on the ecliptic, they stay pretty close to it. Technically, the ecliptic is the apparent path of the sun. It's the only one that stays exactly on that point. The other objects are very, very close to it at all times. We will look at the ecliptic a bit more. But first, let's talk about constellations. In ancient times, stars were grouped together to make stories. I mentioned that before, and that, okay, you don't have a calendar. How do you know to go out and harvest your crops so you don't starve in the winter? You say, well, it gets darker earlier. You don't have a clock either. It just gets dark when the sun sets. That's all you know. So what you do is you start keeping track of the stars. And you say, well, when we see this grouping of stars, right after sunset, winter's coming, it's going to get cold, our plants are going to die. If we don't do something with them, we're going to die. How do I remember what that group of stars looks like? So I make up a story about it. It's a big hunter facing a serious bull coming across the sky. And so you get a fanciful drawing that looks like this. This is the hunter Orion holding his club above his head. I'm not sure why this drawing is in French, but it is. So there's Orion the hunter holding his club above his head, with the charging bull, Le Taureau, or Taurus, coming at him and charging right at. So this serves as a way of telling the story. But what you find doesn't always match up with reality. The pictures made it easier to remember, but they don't look like that. So there's the actual picture, or the drawing, I should say. There is a photograph of the exact same region of the sky. Unless you have the brightness turned up on your monitor or screen, it's going to be hard to see this there at all. I will say this was taken by a phone sitting on Johns Island, South Carolina. Not the darkest location, but I was able to easily see Orion, and you can see Taurus. If you look closely at it, you can see the V shape of the bull's head of Taurus. And then you see the 3 stars that particularly make up what's known as Orion's belt. So that is the belt of Orion. Just below that, there are 3 more stars. The middle one is the Orion Nebula that I talked about in the introductory video. Another fanciful drawing. This is Perseus and Caput Medusa. Caput is head. So this is the hero Perseus who slain the Gorgon Medusa by slicing her head off. One look from Medusa would turn a man to stone, so goes the legend. You see all the little dots in each Perseus and the head of Medusa? Those are stars. And you can see that somebody's got a big imagination if they think that looks like the actual picture that you see here, the drawing. But notice the little line around it. That was how constellations were originally defined. That you just imagined a picture up in the sky, as we just saw with Orion. It doesn't look like that, actually. And then you said anything around this is said to be in that constellation. Ancient societies actually thought all the stars were the same distance away. We now know that some stars are much closer, some stars are much farther away. So we say you're looking in the same direction when you see this. Here's another couple of constellations. This is Sagittarius, the Archer. Probably heard of that one before. And Scorpius, the Scorpion. And the very modern Telescopium sitting there in the middle. Again, an illustration of this, the thing that looks like a river is the Milky Way, a river of white stars going across. You see just a ton of stars going across. If you ever see a long exposure photograph of the nighttime sky, you might see the Milky Way in it. It's got all these different colors, the way people process the photos. But ancient societies easily noticed it. It's kind of hard to see here now. Sometimes, though, in the modern world especially, we don't just look at the overall constellation. We find a smaller portion of it that's easier to recognize. So if I bring back up that picture of Sagittarius and Scorpius, they don't look like this. I've mentioned that a couple times. They look more like this. This is an illustration of what's actually going on here. You can kind of work out where things are on this. The left-hand side does not look like an archer at all. In fact, you can see it's labeled as the teapot. And yes, I do want to start singing a kindergartner song right now, but I'm not going to. Astronomers really often refer to a Sagittarius as the teapot, because that is much easier to recognize than the entire constellation. If you have that smaller part of the constellation that's easier to recognize, it is known as an asterism. So the teapot is an asterism in the constellation Sagittarius. And the little thing labeled 3 SGR right beside it is the galactic center. That's where the center of the Milky Way is actually located. We can't see it because there's dark clouds of dust blocking our view, but we know it's there from indirect measurements. Here's another famous asterism, maybe the most famous. This is the constellation Ursa Major. Whomever dreamed up this drawing, I don't think has ever seen a bear. Ursa is bear, Major is big. So this is the big bear. I've never seen a bear with a tail like that personally, but you know, they can draw whatever they wish. This is the constellation. You can see the line around it, and it gives you an idea of what it is, but it's much easier to recognize the asterism that looks like this. This sort of looks like a soup ladle, or to use as sort of an archaic term, a dipper. So this is the Big Dipper. Think of it as a ladle dipping out soup. It is supposed to be the tail and sort of the rear of the bear. That's what this represents. It is actually much easier to find the Big Dipper asterism than it is all the stars of Ursa Major, the constellation. Notice the names of the stars. They're almost always in Arabic. The constellations have Latin names, but the stars have Arabic names because the Arabic world kept up the knowledge of the ancient Greeks after the Roman Empire fell, and so we end up with these Arabic names. If you start seeing words with AL at the beginning, that usually comes from Arabic. You might notice on this picture Alcor and Mizar, that means horse and rider. There are two stars very, very close to each other as we see them. This is a two-dimensional representation of a large portion of the sky. It doesn't show you everything. Just like you could look at a world map of the Earth and say, well, this is what the Earth looks like. No, the Earth's a sphere, but we get an idea. This map works. So this shows us where the stars are on this. A couple of things to point out. That wavy line going through the center is the ecliptic. That's where you can find the sun at various points. If you look at these, you can start to see some of these things that you've probably heard of. There are 13 constellations along the ecliptic. They are all collectively known as the zodiac. And now I have to get it out of the way. This is astronomy, a science, not astrology, which is a religion. So astrology comes to us from Babylonia. We don't do astrology. We don't do horoscopes in here. Astrology comes from Babylonia, and it says that the location of the sun, the moon, and the planets at the moment of a person's birth tells everything about that person. I have to, if I ever meet an astrologer or someone who's really interested in it, I just ask them, do they account for Neptune? And they'll say yes. And I'll say, well, the Babylonians didn't, because Neptune wasn't known in ancient Babylonia. What about Pluto? Well, yeah, you got to take it into account. It's not a planet. All these debates go on in that. I will just say, if you like to look at astrology, I would recommend you read all the horoscopes and pick one that you like, because they're all pretty much written vaguely enough to be satisfying for everyone. And there's another little thing about it. The sky has changed over time. Ever since ancient Babylonia, the Earth has wobbled. Mentioned that last time, talking about the precession, the spinning top, the North Pole changing direction. The constellations are off, usually by 1. My birthday is in early August. According to most astrology horoscopes, I'm supposed to be a Leo. On the date of my birth, the sun is in the constellation Cancer. Every constellation has shifted over at least one. If you're in between two, you might still be in the same one as before. So there's another reason to take those horoscopes a little bit lightly. The whole system has changed. And I did say there's 13. You might have heard of 12. 13? Yes. Over on the right-hand side of this picture, there is a constellation that dips down into the ecliptic. This is known as Ophiuchus. Ophiuchus is the snake handler. If you have a birthday in late November to early December, congratulations. Your sign, astrological sign, is snake handler. The slideshow itself, if you look at the notes that's included with this, it has a link showing the dates for the sun entering each constellation. This year, it tells you how these things, you can actually find out what constellation you would actually be in according to the position of the sun. And that's another thing about astrology. Astrology says it's all the planets and everything else that makes a difference. What's printed up online is usually just where the sun is, which, it's just leaving out a whole lot of things, although I don't think it's leaving out much in that regard. Another term is the celestial equator. Talked about that. It's directly above the Earth's equator, and it's a straight line across the middle. Celestial equator tells us that's above the Earth's equator. And you'll notice that the ecliptic, the path of the sun and the planets and the moon, is not on it. Well, it crosses it twice. Crosses it on the left side, which is the exact same as the right-hand side, and it crosses it in the middle. Those 13 constellations along the ecliptic are collectively known as the zodiac. I mentioned that a little earlier. Nowadays, however, we define constellations a little bit differently. First of all, we realize that the stars are not the same distance away. Some are closer, some are farther away. So we don't really associate these with pictures anymore. Imagine this. You're going to North Carolina. You're driving along. You might see a sign on the side of the road that says, "Welcome to North Carolina." Chances are, though, you will not see a line across the road. Just don't see those too often. And if you're walking across the line, there's definitely no line there. It's just where someone said, "This is South Carolina, this is North Carolina, and this is the marker that we just don't put a picture of. We'll just know it's there." That's a state boundary, a state line. We treat constellations like state lines nowadays. We say that if a star is in this defined area of space, it is in that constellation. That's very much like saying this town is in South Carolina, the town 5 miles away is in North Carolina, or Georgia, or, well, those are the only two states that South Carolina borders. But you can say that, you have this one town on this side, one town on this side. They're in different states. Same thing with stars. This star looks like it's in that direction. This star looks like it's in this direction. They are in different constellations. The brightest star in a constellation is given the designation of Alpha, the first letter in the Greek alphabet. Hey, that's where alphabet comes from, Alpha. The brightest star is Alpha, then Beta, then Gamma, Delta, Epsilon, and so forth. This is what we think, how we define modern constellations. Notice there's no portraits of heroes, hunters, bulls, teapots, any of those things. This is very much like the state line boundaries you see on a map, a two-dimensional map of the Earth, and it shows you where these things are. It's a little different from the way the other one was. It's kind of backwards, looking at it this way. And you can see Ophiuchus over here on the left-hand side as it comes in and shows you where it actually is. A few more points on the celestial sphere we need to note. Since the ecliptic is not lined up with the equator, the sun appears to be above the equator at some points and below the equator, or north of the equator and south of the equator. The northernmost point on the ecliptic is known as the summer solstice. We tend to think of this as a day. It's not actually a day. It is a celestial coordinate. It is the northernmost point on the ecliptic. And the sun will reach this around June the 22nd each year. We have to say around because we have 24 time zones on Earth. And sometimes it could be June the 21st, sometimes it could be June the 22nd, sometimes it could be June the 23rd, depending on where you are on the planet. But when the sun hits that northernmost point, that is said to be the start of summer. So if you hear a meteorologist say summer begins at 7:56 a.m. today, that means that the sun has just reached that northernmost point on its path. The winter solstice is when the sun reaches the southernmost point on the ecliptic. And this typically happens around December 22nd. Here in the northern hemisphere, that means we get a lot less daylight. So a lot less daylight, you have more darkness. The summertime, you have much more dark daylight. You typically have over 14 hours of daylight and less than 10 of darkness. It's the exact opposite in December. Ancient societies, at least in the northern hemisphere, noticed this, and rituals developed about it. Rituals such as, all the leaves fell off the trees a month ago. I know what I'll do. I'll bring a tree that still has, well, not leaves, but needles into my house and remind me that the leaves will come back. I'll see green, just like I will see in a few months when spring comes around. And then, since it's so dark outside, I'm going to light candles all around to bring the light back inside. Yeah, that sounds really, really familiar. As soon as the Christian church became established, to combat some of the winter solstice rituals that had developed in paganism, some of the winter solstice rituals were adapted into Christianity and given meanings appropriate to Christianity about eternal and light and so forth. But most of the things that happened around December 22nd or maybe December 25th come about because of winter solstice rituals, because the low amount of sunlight on that day, the long nights that you might have, and it's typically cold at that point. The sun has to cross the equator twice if it goes from north to south. When it crosses the equator from the southern half to the northern half, we call this the vernal equinox. This is often referred to as the first day of spring. This is usually March the 20th, although it can vary. Equinox, by the way, means equal night. Typically, you have 12 hours of daylight and 12 hours of darkness. So it is equal day, equal night, equinox. The autumnal equinox is the opposite, is when the sun crosses the equator from the north to the south. So when the sun goes from below the equator to above, that is vernal. When it goes from above to below, that is autumnal or fall equinox. And that usually happens on September the 22nd. Back to our drawing or a map that shows you these things. I've labeled the vernal equinox. The autumnal equinox is on the right or left-hand side. Again, this thing is supposed to make a loop around to make one big circle. The winter solstice is marked as the southernmost point on the ecliptic. For some reason, that yellow does not show up too well, but that is the summer solstice at the northernmost point. We got to define a few coordinates. Celestial coordinates. Declination. Declination corresponds to latitude on Earth. Latitude tells you how far north or south you are of the equator, and it ranges from 0 to 90 degrees. So Charleston is 33 degrees north of the equator. If you go from the center of the Earth out to the equator and then draw a line up to Charleston, that will make a 33-degree angle. If you go around the globe at 33 degrees north, you'll reach places like Baghdad, Iraq, a few others. You will not hit Europe. If you sail due east from Charleston, the next country you hit is Morocco, which is in North Africa. So that corresponds to north or south. We don't say north or south in using this declination coordinate. We say plus or minus. Plus is above or north, minus is south of the equator. The summer solstice declination is plus 23.5 degrees. That's a number we're going to see over and over and over, and it has a big significance about what happens here on Earth. The coordinate that corresponds to longitude is right ascension, or RA for short. This measures how far east or west you are of an imaginary point. On Earth, that imaginary point for longitude is the prime meridian, which runs through Greenwich, England. Why there? Because England had a powerful navy when everything was starting to be determined in this way. So they get the starting point in that. The celestial point that starts this is the vernal equinox, that point when the sun crosses the equator from the southern half to the northern half of the sky. Right ascension is not measured in degrees, it is measured in hours. I mentioned that before, talking about degrees, minutes, seconds, and hours. Every hour is 15 degrees. 15 times 24 is 360. The summer solstice right ascension is 6 hours. The autumnal equinox right ascension is 12 hours. The winter solstice is 18 hours, and so forth. There are some telescopes that can actually go through and have all of this stored, some of these coordinates stored. You see there's vertical and horizontal lines here. Once you set up the telescope significantly, it will go around and you tell it, I want to go look at this place, and the telescope will swing there automatically. Modern telescopes are capable of doing that, which makes them a little bit easier to do. So there's our picture of the star chart again. We'll look at this a little bit more a little bit later. But let's come back to Earth. Instead of looking up at the sky, let's relate some of this to Earth. There's that two-dimensional map of the Earth I've been talking about. So you see North and South America on the left-hand side, Africa, and then Europe, Asia up to upper right, Australia, New Zealand way off down to the lower right, and Antarctica all across the bottom. As with most maps, if you print it out in this way, this scale's not that big. I mean, it makes everything near the poles look really big compared to other places. For example, Greenland is not that big white spot up in the north. Greenland is actually smaller than Texas, but it looks huge the way this map is projected. So our 23.5 degrees, that shows up a couple places on Earth. If you go to 23.5 degrees north of the equator, you reach the Tropic of Cancer. The sun is directly overhead at this location on the day of the summer solstice. Think about Eratosthenes in the well in Syene in modern-day Egypt, which if I look over at Africa on this map is at about 23.5 degrees. That dashed line that goes across there going toward the Arabian Peninsula. At the day of the summer solstice, the sun is directly overhead. This is as far north as you can go on Earth and have the sun directly overhead one day out of the year. This thing should really be called the Tropic of Taurus because on the day that the summer solstice happens, the sun is in the direction of the constellation Taurus because of the changing skies. If you go further north, you will never be able to see the sun directly overhead, not at all throughout the entire year. The Tropic of Capricorn is at 23.5 degrees south, and that's as far south as you can go and have the sun appear directly overhead one day of the year. If we take 23.5 from 90, we get 66.5. And at 66.5 degrees north, you find the Arctic Circle. And at 66.5 degrees south, you find the Antarctic Circle. At these locations, some unusual things can happen. If you're standing at 66.5 degrees north, the Arctic Circle, which means you're in Alaska, far northern Canada, a little bit of Norway, Finland, Sweden, and then Russia. That's about the only places where you can be to have this happen. If you're standing at the Arctic Circle, on the day of the vernal equinox, the sun rises. And it sets on the day of the autumnal equinox, which means, actually that's at the pole, excuse me. If you're at the Arctic Circle, that happens on the day of the summer solstice. If you're at the Arctic Circle on the day of the summer solstice, the sun does not rise, does not set, it's there all day long. If you're at the Arctic Circle on the day of the winter solstice, you don't see the sun at all. It never rises above the horizon. Same thing goes with the Antarctic Circle, but there, if you're at the Antarctic Circle at the winter solstice, the sun stays up the entire time. It does not set. If you go to the poles, it gets a little bit different. Back to a few terms here. We mentioned zenith. Zenith is the point directly overhead. Your zenith declination, the celestial coordinate that corresponds to pointing straight up in the air, is equal to your local latitude. So in Charleston, the Charleston area, 33 degrees north of the equator, our zenith is plus 33. If you ever want to have a star, you want to study a star that goes directly overhead, it needs to have a declination of plus 33 degrees. The North Pole is at 90 degrees north, so therefore the zenith at the North Pole is a declination of 90, which is the North Celestial Pole. The horizon declination is your local latitude plus or minus 90. What that means in Charleston is our local southern horizon, at least, is minus 57. We cannot see any star that has a declination below 57 degrees because it can never come above our horizon. If you're at the pole, your horizon is 0, which is the equator. And as I mentioned, if you're at the South Pole, sun crosses the equator going north at the day of the vernal equinox, that is crossing your horizon, which means the sun just set. And it doesn't come back above the horizon until the autumnal equinox in September. Already mentioned that the Tropic of Cancer is the northernmost point you can see the sun directly overhead, and that it should be the Tropic of Taurus. The Tropic of Capricorn is the southernmost point where you can actually be and see the sun directly overhead. If you're in between these two, you typically have consistent warm weather throughout the year. The sun never varies too much. It doesn't go too far north. It doesn't go too far south in our view in that point. And you find out that the sun pretty much rises at 6 and sets at 6 throughout the year. It doesn't change much like it does at other latitudes on the Earth. Arctic Circle, Antarctic Circle, one day of the year the sun will never set. Another day the sun never rises. So keep this in mind. If your lifelong dream is to go study penguins, I would really advise you to not go to the North Pole in December. There are three reasons why. The first reason is if you're at the North Pole in December, there's no sunlight. You cannot see anything around you. The second reason is there's no land at the North Pole. There's ice. The Arctic Ocean sits up there and there's ice covering it, and the only land we have is at the bottom of the ocean, so there's no place for you to really stand. And the third thing is penguins don't live at the North Pole. Penguins only live at the South Pole. So if you're going to go study penguins, don't go to the North Pole in December. Instead, go to the South Pole in December. At the South Pole in December, you will have 24 hours of daylight, and that's where the penguins actually live, and Antarctica is a continent for you to actually stand on. Next time, we'll continue on looking at some ideas that have been developed and work our way up to the modern times.